example 3, we're going to find y prime if the sine of x plus y is equal to y squared times the cosine of x. So the first step is that we're going to be differentiating implicitly with respect to x and remembering that y is a function of x. So we're going to get the following. Okay, so let's write out what our function looks like. So we have the sine of x plus y, and that's equal to y squared times the cosine of x. Okay, and so now what we're going to do is, again, we're going to differentiate implicitly with respect to x, and remembering that y is a function of x, then we're going to get the following. So for part 3 here, okay, we first want to find, on the left side, we're going to use the chain rule. Okay, so that means what is the derivative of sine? Well, the derivative of sine is the cosine, so that's the cosine of x plus y times the derivative of what's inside, which is x plus y. So what is the derivative of x plus y with respect to x? Well, the derivative of x is going to give us 1, plus the derivative of y is going to give us y prime, equals. Now on the left side, we're going to use the product rule and the chain rule on that side. So we have y squared times the cosine of x. So what is the derivative of the cosine of x? Well, that means it's going to be y squared times the derivative of the cosine of x, which is negative sine of x. Okay, and then plus, okay, we have the cosine of x times the derivative of y squared. Well, what is the derivative of y squared? Well, it's 2y times y prime. Now again, let's make note here, okay? Note, again, that we have used the chain rule on the left side and the product rule and chain rule on the right side. Okay, now what we want to do is we want to be able to collect all the terms that contain y prime on one side of the equation. Okay, so when we do that, we're going to multiply the cosine of x plus y and distributing it to those terms. So we end up getting the cosine of x plus y plus y prime times the cosine of x plus y. And that's equal to the negative y squared of the sine of x plus we have 2y prime times the cosine of x. Okay, so now we're going to collect all the y primes on the left side of the equation. So we have y prime times the cosine of x plus y minus 2y times y prime of the cosine of x. And then that's going to equal negative y squared times the sine of x minus the cosine of x plus y. Okay, now let's go ahead and then factor out the y prime. If we factor out the y prime, then what's left is the cosine of x plus y minus 2y times the cosine of x, and that's equal to the right side, so we can factor out, let's say, a negative 1. So if we factor out a negative 1, then we end up with y squared times the sine of x plus the cosine of x plus y. Okay, and now by solving for y prime, we're going to divide both sides by the cosine of x plus y minus 2y times the cosine of x. So in order to get y prime on its own, we have negative 1 in the numerator times y squared times the sine of x plus the cosine of x plus y divided by the cosine of x plus y minus 2y times the cosine of x. Okay, now if we want to make this look a negative 1 in a denominator, so if we did that, we would still have negative 1 factored out in the numerator, which is y squared times the sine of x plus the cosine of x plus y. And then if we factored out a negative 1 here, then that means that we're going to have the negative 2y cosine of x is now going to be positive, so it's going to be 2y times the cosine of x. And then it's going to be minus the cosine of x plus y. So what happens is this negative 1 divided by this negative 1 makes it positive. So then ultimately what we're going to get for y prime is the following. So in the numerator we have y squared times the sine of x plus the cosine of x plus y divided by 2y times the cosine of x minus cosine of x plus y. Okay, now let's go ahead and graph the original function. So the original function is we have the sine of x plus y, and that's equal to y squared times the cosine of x. So there is our graph. Okay, so we can take a look here. What's happening right over here? Well, let's go ahead and copy and paste this graph so we can see what's happening. Okay, so I want you to notice, okay, that as a check on our calculation, notice that y prime equals negative 1 when x is 0 and y is 0. And it appears from the graph that if you look at this line here, the slope is approximately negative 1 at the origin.